Alright, so we're on lesson 50, talking about scientific notation, and this is very useful for in science when you have very large numbers, like the number of people in the world, or the number of stars, or the weight of huge things. And it's also very useful for very small things like the weight of a molecule, or how long it is for a grain of sand. So we're going to be using multiplying by tens. So everybody should know that when we multiply a number by 10, we're moving that decimal plane over. So if I have 5.34 and I multiply that by 10, that moves the decimal place over one place, and now the decimal place is between the 3 and the 4. Okay, and what we're going to be doing with scientific notation is we're going to be using, I don't want to write a whole bunch of tens, so we're going to use exponents. So if I make this 5.34 times 10 to the fourth, we're going to move the decimal place 4 times because we're multiplying by 10 4 times. And so everybody should know that when we move the decimal place, if I don't have another one, I always have more zeros behind the decimal place. So it's going to be 5, 3, 4, and I already moved it 1, 2 to get to that, and then I'm going to put 2 more zeros so that now I've moved it 4 spaces. And now, even if we don't see a decimal place, we know there's always one behind the last digit there. Okay, so in order for a number to be in scientific notation, you have to have a digit in front of the decimal place that is between 1 and 9. And so this right here would be in scientific notation. If I were to write 0.534 times 10 to the fifth, that's no longer in scientific notation because I don't have a number in front of the decimal place that is between 1 and 9. Okay, so this one would not be considered in scientific notation. So that's with positive integers as our exponent there. Okay, so let's go ahead on lesson 50. We're going to start with practice A on page 164. So we're given 476,000, and they want us to write that in scientific notation. So I'm going to have to write this number with the 4 is going to be in front of the decimal place, and then everything else is behind the decimal place, and I don't need to write those extra zeros. You could always write the extra zeros, but it doesn't help anything. So this is another thing that writing in scientific notation does. It gets rid of extra zeros. And then we're going to put that times 10 to how many places did I move the decimal place to get it behind the 4. So I count 1, 2, 3, 4, 5. So that would be 10 to the fifth. Okay, so if I were to do this again and move it back to where it was, you could see that it takes 5 moves of multiplying by 10 to get it back where it was. Okay, and let's go ahead and jump to C because we're still dealing with positive integers, positive ones, and so this one is 30,560,000, and we want to change that to scientific notation. So again, I want to put the decimal place behind the first non-zero digit. So we're going to have 3.0 5, 6. This is a good example. Make sure you can't take out the zeros that's between other non-zero digits, just the ones at the back. Okay, and then we're going to multiply that by 10, and we're going to count how many spaces do I have to move my decimal place to get it up there. 1, 2, 3, 4, 5, 6, 7. So it's 10 to the 7th power. Okay, so that's dealing with positives, and I'm kind of disappointed that the book threw in, we're also going to be doing negative exponents, which we haven't dealt with a lot of negatives besides, I think, in the graphing. So we know that when we multiply by 10, we're moving the decimal place to the right, and if I was to divide by 10, I'd be moving the other way. So an important thing to look at right now is we know that when we have positive exponents, that means we're multiplying a bunch of that thing together. So 10 to the 5th, I've got multiplying by 10 of them, 10 to the 3rd, or multiplying by 5 tens. 10 to the 3rd, I've got 3 of them. 10 to the 2nd, we're multiplying 2 of them together. 10 to the 1st power is just a 10. 10 to the 0 power, I think I've told you guys this before, if anything to the 0 power is going to equal 1. No matter what that thing is, except for 0, you can't raise 0 to the 0 power. But anything else is 1. And now we've got the question of, what do we do when we want to, we got 0, so what is it going to mean when I do a negative exponent? So 10 to the negative 1 is actually going to be the same as dividing by that. So each time, you see as we went down from 5 to 4 to 3, each time we're getting rid of a 10. So if I keep going down, I'm actually going to be dividing by 10 now. Okay, so that's 10 to the negative 1 is dividing by 10, or 1 over 10. Because we got the 1 there, remember, we always got a 1. And then if I've got 10 to the 2nd, that's like doing it twice, or dividing by 10 times 10 on the bottom, or 1 over 100. And keep going with that. It's like dividing by 3 tens here. And that's 1 over 1,000. Okay, there we go. And so we're going to be using this for numbers that are smaller than 1. So if we look at practice problem B, we see that that is 0.000476, and we want to change that to scientific notation. So that's going to be 4. I have to go to the first non-zero one and put the decimal place behind that. So 4.76, and we're going to times that by 10, and this time we're going to use negative exponents. So I'm going to see how many places I'd have to move it to get it behind the 4. 1, 2, 3, 4. So that's going to be to the negative 4. So if I took this number here and divided it by 10 4 times, I would be back to having the decimal place up here. Okay. And let's do that with D as well. We've got 0.0000. How many zeros do we got here? 1, 2, 3, 4, 5 zeros, and then the 3, 0, 5, 6. Okay, got the camera. Okay. So again, we're going to put it the decimal place behind the first non-zero digit, and we have 3.56 times 10 to how many spaces did we move it? 1, 2, 3, 4, 5, 6. So that would be to the negative sixth power. Okay, so that's putting numbers that are in normal notation and changing them into scientific notation. And then E here, we're going to start with the scientific notation. So they give us 4.06 times 10 to the fifth, and they want us to write that in standard notation. So I'm going to write this, and then since I'm doing positive exponent here, a positive 5, that means I'm going to be moving my decimal place to the right. So I'm going to write 406, and then it was here. I'm going to move 1, 2, 3, 4, 5 spaces. Now it's back here. You don't have to write it there. We all know that the decimal place is behind there. I'm going to put a comma here. So it's 406,000. Okay, and then F, we've got 4.72 times 10 to the negative 6. And since we have a negative exponent here, we know that we're going to be same thing as dividing by 10 6 times. So we're going to have to move this decimal place 6 times. So I know that I'm going to move it to in front of the 4 would be 1. So I'm going to need 5 zeros there in front of it. So I'm going to have a 0, and then that's where my decimal place is going to be. And I'm going to have 1, 2, 3, 4, 5 zeros, and then the 4, 7, 2. Oh, I'm sorry, that was not on the camera. Okay, and so you can see if I was to reverse this and move it back 6 spaces, that's where it would be between the 4 and the 7 again. All right, and that is the basics of scientific notation. Again, this is going to be something that is going to be used in a lot of science classes like chemistry and physics and other higher maths that you're going to take later on. Okay, and that's it.